Hello, in this tutorial, we'll review the quality of the static timing analysis or STA results for the timer design. The timing reports are generated during the physical implementation flow. We will review the sign-off STA results that could be found in the Run folder under the directory reports/signoff. If you need an introduction to timing analysis or timing closure, please check the timing closure document in the description below. The sign-off STA is performed on 9 timing corners, which are combinations of 3 PVT corners, fast, slow, typical, and 3 interconnect corners, min, max, and nominal. The star-RCX_STA star.rpt reports are for the typical nominal corner, and the directories star-MCA include the min, max, and nominal corner combinations respectively. Before we start, please make sure that you have created a repository, cloned and run setup, already developed the timer's RTL, integrated the design into the user project wrapper, and completed physical implementation successfully, as demonstrated in the previous videos. We will review the user project timer results and then move on to the user project wrapper with the timer macro integrated. Since the macro is inserted in the user project wrapper with no standard cells on the top level, the results are expected to be almost the same. For other implementations, it may not be the case, so it is recommended to always review all hardened macros sign-off STA results. Let's start by verifying the STA inputs. They include the timing constraints, or SDC file, the design and sub-macro files, gate level, netlist, and parasitic extraction file SPEF, or timing models, and the technology libraries. All inputs are handled by the flow except for the STC, which is the base STC provided in the configuration. Firstly, let's review the unconstrained endpoints to ensure that the STC covers the design. Go to the end of the 33-RCX_STA.checks.rpt file and review check_setup reported warnings. The pins that don't have an input delay constraint are asynchronous inputs, IO_in star, and they are not used in the design, so this is not an issue. As the unconstrained endpoints are asynchronous outputs, IO_OEB and IO_out from the design, they are not required to meet an output delay relative to the system clock. Next, we will verify that the parasitic annotation from the SPEFs cover the design. Go to the star-MCA/RCX_star_STA.checks.rpt files and review the report_parasitic_annotation section for the reported unannotated nets. The reported nets are in the IO_in star pins that are not used in the design and are unconnected, so they don't have any parasitics. Additionally, reported nets are the unconnected constant output from the Sky130 CON-B1 standard cells. Therefore, all the unannotated nets are fine. We have verified that the input STC is not missing any constraints and the parasitics annotation has been done successfully. Now we will begin reviewing the results reported by the STA tool since we verified that the inputs don't have any issues. To determine the worst case hold and setup slacks, go to the star-MCA/RCX_star_STA.summary.rpt file and determine the minimum slacks. For the hold slack, the minimum is plus 0.2 nanoseconds at the minimum corner. Then go to 28-MCA/RCX_min_STA.min.rpt and look for the minimum slack to determine the PVT corner. The critical path is reported at the fast min corner. From the path, we can verify that the clock is propagated since the clock delay till the flip-flop is accounted for. Additionally, the clock uncertainty is 0.25 nanoseconds, which is the one used for implementation, and it should be in the range of 0.1 to 0.15 nanoseconds for sign-off. Therefore, the achieved hold slack is pretty good, generally a positive hold slack of 0.05 nanoseconds or more with this implementation clock uncertainty is acceptable. For the setup slack, the minimum is plus 11.20 nanoseconds at the max corner. Then go to the 30-MCA/RCX_max_STA.max.rpt file and look for the minimum slack to determine the PBT corner. The critical path is reported at the fast max corner. From the path is verified that the clock is propagated and the reset input delay is set. As well, the setup clock slack is considerable, which allows operating at a faster clock of a period of as low as 15 nanoseconds. The next step is to review the maximum capacitance and transition violations. Design doesn't have any setup or hold violations, but is recommended to verify that there aren't any severe maximum capacitance or transition violations, as they may indicate implementation issues such as long routes or improperly buffered nets. Go to the star-mca/rcx_star_sta.checks.rpt file and review the report_checks_types results. There are no maximum capacitance violations at all corners. For maximum transition, constraint is set to 1 nanosecond for better implementation, or for sign-off, it should be 1.5 nanoseconds for Sky 130 technology. Therefore, the reported violations are not actual violations. Moreover, the achieved maximum actual transition of 1.09 nanoseconds is great for this node. Finally, the maximum fan-out is a soft constraint that is used to ensure that the design doesn't include huge fan-out on the nets. The net with the violation has the highest wire length and is connected to 9 antenna diodes. Therefore, the fan-out violation of 2 is acceptable since there are no other violations in the design. Now we'll repeat the same process to review the user project wrapper sign-off STA results. Go to the end of the 21-RCX_STA.checks.rpt file and review the check_setup reported warnings. The reported pins include the identified pins from the timer macro, as well as unused ports of the user project wrapper and analog connections to analog_IO star. Then go to the star-mca/rcx_star_sta.checks.rpt files and review the report_parasitic_annotation section for reported unannotated nets. The reported nets include the identified nets from the timer macro, as well as unused nets of the user project wrapper. Therefore, no new issues are identified. Next, we will review the STA results. Determine the worst hold and setup slacks by checking the minimum from star-mca/rcx_star_sta.summary.report. We find that the hold and setup slacks are plus 0.2 nanoseconds and plus 11.20 nanoseconds, with the same critical paths as found previously. Moreover, there aren't any maximum transition or capacitance violations. That concludes this tutorial on reviewing STA quality of results. In the next video, we will work through STA for the full Caravelle chip with the integrated user project wrapper.